back in 2020-21. So for them, I want to say welcome back once again after a long time. Indeed, during the COVID-19 pandemic only, we realized the need for forming a platform where like-minded people can come together, listen to the eminent scientists all over the world, share, interact, and learn in a fruitful collaboration. So as we are from cellular automata, so our focus obviously was from cellular automata and broadly on the theoretical computer science. So from there, this open research group, Cellular Automata India, was born. And we have traveled a long path from there. Indian Summer School on Cellular Automata has been started, which is running the fourth edition currently. Then ASCAT, the Asian Symposium on Cellular Automata Technology, a new symposium series that was started. But meanwhile, we took a long break, maybe to come out of the lag of purely online lectures that was forced upon to us by the pandemic. Now everything is back to normal. Our normal routines are restored from all throughout the world. And probably like now, you can also realize that if you want to initiate a discussion where we can introspect different perspectives and it's not limited to the geographical boundaries, and we also want to listen to the eminent scientists from different fields together on that aspects, then we obviously have to go online for such events. There are no other possibilities. And pandemic has made us learn that this is actually possible and feasible. So here we are once again in a webinar series where together we want to explore and introspect reversibility. And we dedicate this series to the memory of Edward Fredkin, one of the pioneers and advocates of reversible computing, which plays and going to play a pivotal role in quantum computing. So I would like to invite Shupriti to tell us more about what we can expect from this webinar series. So over to you, Shupriti.
Thank you so much, Kamalika-di. On behalf of Cellular Automata India, I, Shupriti Kamila, am going to give a very brief description on this webinar series. So before that, let me first share my screen. So I'm just showing you a very small PPT on that. Just allow me a few seconds to share my screen. Yeah, is my screen visible?
Yes.
Okay. So today, this is our first day of the webinar series on understanding reversibility, Edward Fredkin Memorial Lectures. So before starting, we just let me tell you about some intuitive idea about reversibility or how we can see reversibility. Intuitively, we can say that reversibility is a natural phenomenon where we can reverse back from where we have started. We can reverse back to that point. So a classical example may be the planetary motion in orbits around the star. A deterministic process is called reversible if its direction of execution in time can be reversed, in the sense that if the process runs back in time, it will return to the initial condition without losing any of its properties. But we, the people of Cellular Automata Research Group, how we see this reversibility in our mathematical tool, Cellular Automata. As soon as I am telling you that a mathematical tool, so in that case, how I will see reversibility? That a function which will be bijective, that is injective and surjective. So we understand reversibility through a microscopic model of the complex world, which is cellular automata, where we say that a CA is reversible if every configuration of it has exactly one predecessor and there is obviously no information lost during the evolution of the cellular automata. It directly corresponds to the reversibility of microscopic physical systems implied by the laws of quantum mechanics, and we see this function as bijective function. So when we talk about why the webinar series, why we are basically doing this webinar series, reversibility has several implications in several fields. Many systems and processes in the physical world are reversible. Therefore, as long as we are exploring this reversibility in cellular automata, why not we can explore it to some different perspectives, including this physical world, philosophical aspects, or quantum computing. So during this webinar series, we will explore how to view this reversibility from these different perspectives. This means from different angles. What are the angles? In computational terms, we can say that reversibility refers to the ability to reverse computing processes, ensuring no information is lost, and that one can return to a previous state. And when we call for physical phenomena, the concept of reversibility serves as a crucial theoretical tool for understanding the limits of physical laws and the potential for energy and information recovery in idealized scenarios. When we see the philosophical angle of reversibility, we can connect the concept of reversibility in Indian or Western philosophy, also examines the concept of reversibility in logic alongside a discussion on digital philosophy and the counter views. Last but not the least, let us dedicate this webinar series to the contributions of Edward Fredkin, who was one of the pioneers in reversible computing and whom we lost on June 13, 2023. In his remarkable work on digital philosophy, Fredkin proposed that the universe is ultimately digital and computable. That is, if we consider it as space-time, then the space-time is discrete and may operate like cellular automaton. And he has explored the ideas about how physical processes can be viewed as computational processes. So if the universe is digital, if the space-time is discrete, Fredkin's perspective suggests that a reversible universal cellular automaton could serve as one of the simplest ways to represent dynamics. So here we get the motivation to get closer examination of reversible cellular automata. So through Fredkin's perspective, we share the same view on reversibility. Now, just let us hear something from Fredkin's own voice. A very brief video I will play from Fredkin's own voice here. Just let me allow this to play.
Reversible computing. Hi, this is Ed Fredkin, and I'm going to talk to you about reversible computing. It's a very interesting question that was around for a long time in the computer field. Can computers run backwards, be reversed? And the answer is superficially, it's no. A regular computer, you know, can't run backwards, but it's possible to design a computer that can run backwards, and it would run forwards and backwards. Okay, so that's, and there was a question whether you could do that even, and that's what I worked on a long time ago. Okay, I was at BBN around the.
Okay. So with that, we will start our today's webinar series. And again, I am sharing the screen for the presentation to just show you our complete schedule that we have already shared with you, everyone. Uh, and our first speaker today is Professor Susmita Surpole, and followed by our next speaker will be Professor Kenichi Morita. So we are very interested and enthusiastic to listen to them and their talk. So I would like to request Kamalika Di to introduce Professor Susmita Surpole, and we are eagerly waiting for her to for her talk. Okay. Thank you so much.